Okay, so we're making a app today for the GitHub API we can pull from. So that's where we could just kind of, Horace is usually here too, and he usually thinks up all the ideas that we do. He just has like a list of them. And yeah, that's all he does. He just lays in bed. Well, thanks. But if you go to the GitHub API, there's just like tons and tons of data. And it's all, there's a lot of event data, activity, events. So here, I'll just do pull up some events here. So if we go and actually go just to the API, github.com, v3, there we go. So they just keep pushing these out, and you can actually just refresh this thing. I think every few seconds it'll, there you go. But they have like create events where you create new repositories. This is all just like public events on GitHub. So this guy here created a repository, this repository here, you know, like seconds ago. Here's one where someone pushed code up. Let's see, here's someone who did something on an issue. It's like a subtype 2 a lot of times. I don't see it, but
so it's just
here we go. Opened.
On GitHub.
Yeah, anything public that happens. If you click a button, if you go to create something, push something, sharing. Okay. Yeah, create, push. It's a lot of creates and pushes. Here's an issue. Do something with an issue right here. Yeah, there's a full list of what they are. So if we go to event types of payloads. Yeah, so here's all the events. Yeah, commits. People, whenever people download stuff, people follow other people, all kinds of stuff. So we're going to try to pull in from these. Although we'll probably just start with one of them. Whatever. Probably like the push. Maybe, or maybe we'll just do create. Push is easier to test. There's more of those. So on the push event here, we have, actually, no, let's just copy out one of those. It's easier to read. So API, GitHub. Okay, so push event. Okay, it's right here. Okay, so we want to grab, we don't necessarily need all this information. It's kind of overkill. So we'll probably just grab the ID of the event, the type, the actor, or some part of it at least the login and the ID. URL, let's see. Yeah, we'll probably grab the repo that they're pushing to. And then it's on the payload. We got the commit number or commit that we're sending. We probably don't need a lot of this stuff. So we'll just create something small. I guess maybe I'm jumping ahead of ourselves. So we basically want to create a service where we can start streaming events for people, and we can list whoever we want in there. So we can just kind of, you know, maybe put Turing people in there. You can start grabbing events and making this collection of stuff. And then from that, you know, have this kind of API or repository of data that we can go hit an API for that, and then we can start visualizing the data, or we can just play around with it, or, you know, whatever fun little thing. Really, it's mostly just a way that we can get some decent sized data for something that's, you know, somewhat relevant. People we know, or we could just push stuff open. Like maybe we want to have like a little blinky light thing that I was showing you earlier. You know, we could have that blink blue whenever, I don't know, someone from some certain posse pushes or whatever. Just, you can do whatever you want. That's the idea. Is that making sense? What we're doing? Okay. So we'll pop open. Oh yeah, we need a name too. So if anyone has a name. Short name. I find with open source, short names are really good, even if they don't mean anything. We named one. We did another project called Pi. We just made up the word, or not made up the word Pi, but like we just picked a name. It's an event database. You could do EDB. If you want short. Any takers? EDB. Easy. Yeah, that's all good. Simple database for. Okay. Public, throw a README on there. We'll add a license for MIT. Hey. Okay. So I've got that guy. We'll tone it down. Yeah. What's that?
Saying cool hair.
Oh. What you had before?
Shaggy and bearded.
Okay. Quite a crowd here today. Okay, so I ended up creating a, started simple, just made an edb.go. So, oh, do you have a better name than edb, event database, for our event database?
What do you think?
Okay. Do you think of one in the next couple minutes, then we'll switch it. Okay, so with Go, most of you guys are probably new with Go. So the structure is fairly simple. Like there's, I guess I personally don't feel like there's a whole lot to the language. I mean, it's pretty simple. A lot of times you'll have to do things, like in Ruby, there's a lot of like shortcuts for doing things. With Go, a lot of times it's just writing like an extra line or two of code. Like we don't have, like in Ruby, you might do, 10 times, my Ruby's horrible, X, and then you do something in here, but you just can't do that. In Go, it's always, for I, 0, I is less than 10, I plus plus, and then you do that there. So with Go, I always have a package at the beginning, and the package name pretty much always matches your name of your folder, just the convention. And then from that, you're going to import packages. So this will be any other package we want to use. So a lot of times you'll use like a font package, FMT, which is the format package. So you can do print line, say hello, like that. Okay. And then once you have that, you start making either like types or functions within your program. So we have events in our database, and we have, here's our data right here. Okay, so we have, this is a push event, I guess, or let's just call it an event. So I think a lot of the stuff overlaps between events. I'll call this a GitHub event, that'll work. So we'll do a type GitHub event. Okay. And then we'll have, let's see, we have ID, type, is that a string? Yeah. String, type, string. I got an actor on here. So the types on here are just the classes in Ruby, basically, same thing. You don't have inheritance, so you can't have one class inherit from another one. I like to take the methods and properties. It's all very, very flat. You can do it's called proposition. So if you had type A, what's the word? Actually, that's a little more complicated. You can essentially do B. So if you have a field in here like age, and then a name, you can have B inside of here, and then A will sort of, like it has B inside of it, and you can reference A dot B dot age, if that makes sense. But there's no like, you never say like, is it in Ruby's like this, B or something like that. There's none of that. This will stop me too if I'm going too fast and stuff, right? Gloss over things. Okay, so we have, let's see, actor with an ID and login, and then Just copy this over. So ID string login string.
It's almost like a NoSQL type structure, like that inside of the other one.
Oh, a little. I mean, yeah, in that sense, like it's not relational.
Okay.
You can embed structures inside of other structures. And the nice thing is, in a second, we'll throw on some tags on here, some information, so it can automatically parse the incoming JSON for us. But yeah, it's kind of that. It's just like a nested functional structure. So we have repo struct, and it's an ID, and a name, and URL. Okay, so complete all that. So this GitHub event, a little comment on here. Git represents an event for GitHub. We're done it. So there's this little thing called tags on fields. We do this little backtick, then you have some. You basically have that kind of the format you want to do something with, and a little string you can put things in here. So like we can put the ID or the name of the field that we want to map to ID. So in JSON it's lowercase, it's uppercase here in our field. So we'll just do one for each one of these real quick. Type actor down here is going to be JSON actor and ID JSON repo JSON repo.
So our actor is our user.
Yeah, actor's the person doing the thing, and then yeah, the repository is the thing that they're going against. So right now we're just going to do push events from GitHub. I'll show you real quick. So all the event types, basically an event type for anything you click or do on GitHub. So like even if you download something or you do something on an issue, make a comment, which shows up in this whole stream of API GitHub. It just dumps up the stream constantly with things happening. So we want to pick this up and filter out some subset of users and just store that data. So let me just finish this up real quick. So we'll do D for this one, and then I'll show you an example of how this maps over here. So JSON name JSON. Okay. So this GitHub event, and we want to make sure that it maps between the data coming in and what we expect right here. So quick little test right here. So in Go, testing is super, what's the word, simple. It's not a lot to it. It's really like you would just write Go and then you have basically like a fail command is all you have. So when we import, so we're going to import testing, which is the testing library. And then GitHub, they have some other ones people have made that kind of wrap that do a lot much fancier things. But in general, people are kind of moving towards just a really simple, consistent testing. And then when we create, actually, you know what? Does anyone want to set up Go before we go any further? You can just watch too. Okay. It's really simple if you want to set up Go. We did it before. We can go to, you can do it two ways. You can go to golang.org, download Go. The simpler way, as I found out, is just to do brew install Go, I think it is. Maybe it's Golang. The key takeaway is once you actually download it, you end up with a bash profile. You get these. Can you guys read all this stuff? You end up with a Go path. You need to put a Go path in, and your Go path is kind of where all your Go code on your computer should sit within this directory. So it'll, whenever you download Go code from GitHub or you make your own repository, it'll all go into wherever your Go path is. So I make mine inside the my home directory /Go, and then I'll show you that directory real quick. So this EDB, did you make a new name? Okay,
I'm not feeling creative.
that's all good. Horace isn't here. Do you know what happened?
Yeah.
It's his idea. Okay, so here's our Go directory right here, the path. All their Go code is going to go in, or all the source code goes inside of the source directory. And then from there, we have kind of the location, the site it came from, our username, and then our thing that we're making, or like our actual program, our package name. So this EDB. So if I look in mine, I can see all the Go code I pulled. So this is from all the sites I pulled from. Inside GitHub, there's a bunch of people I've pulled Go code from. Like this is mine right here. These are all different projects. So whenever we want to actually use code in this import statement, everything except for the standard library packages maps from that Go path. So when we're doing tests, we're in the separate package here for EDB test from this package here. So even though we're in the same directory right here, we still have to import kind of the same like the directory we're trying to use, so the package we're trying to use. So this is all relative to that source directory. So EDB, okay. So tests inside of Go are just the word test followed by the name of your test. So we'll just test our GitHub event. Event. I'll just say Marshall JSON. So we just want to make sure that the JSON coming in from GitHub should match, should be able to be parsed by what we have. Should delete that already? Oh, here it is. Okay. So I have this guy.
What did you pass into the parameter there?
So T. Okay, so the format here is you have the argument name first, and then you have the type that it is. So in Go, you'll see stars a lot, with asterisks. That's just a pointer to a type. And the difference between a pointer to a type and just the type itself. I'll do an example here. We'll jump around a little bit. There's the Go playground. So if you ever want to write Go and throw it away, this is where you go. Just play.golang.org. So you can run this, and it'll run it, execute on someone's server, and then show you the output. So this one here, we have package main. So like whenever you write a CLI, or like your final binary that you're going to write, it's always in package main. And we import the func package, and then here's the func print line. Hello playground. It's run from this this main directory, or this main function, which is your entry point into your program. Just making sense. Okay. So if we have, when talking about types, so we'll make a type T struct. We'll say name string. So we have the structure called T, this type called T, and it's a structure that has a name inside of it. Okay. So we'll make a var x of type T. So we're just saying that this variable x is going to be T. Okay. So if we did x.name is equal to Bob, and then we want to print this out. X.name, we should see Bob. Make it Bob. Okay. Not too hard so far. If we want to make a function, so the trick with Go is, actually, we'll do this. So set name. We'll have a T and name string. Okay, so the set name function is going to take a T, or something of type T. Oops, sorry, type T. It's going to be called T. Oh, that's confusing. That's, you see that a lot in Go. They're short, really like they're one-letter names all over the place, and yeah, they're just short. The idea is, okay, so the idea, people get hung up on this a lot. Some people think you should have really descriptive names. It really depends on the context of the name. So this T right here is short because we're only going to use it in this function. It's localized. And if our function was huge, then maybe we need to have it more descriptive because you'd have more to look at. But this is going to be one line, so we really don't need it too large. So if we say t.name is equal to name, and we call it from up here, set name. So we're going to pass an X. We're going to change his name to Susie. And then we're going to print out what the name is. So The tricky part here, when you run this, is it's still going to say Bob. So what happens is that everything in Go is there's what's called pass by value or pass by reference. And languages, if you do like Java, certain types of things like primitive values, like integers and strings, integers and strings and like floating point numbers are all passed by value. Yeah, so they're actually copied to the function you're calling to. Okay. Whereas objects, like our structure down here, this would be passed by reference. So like when you pass it in, you're not passing, like you're not copying the whole structure. You're leaving the structure where it is, and you're just telling the function, here's a pointer to where I want to be. Okay. Whereas in Go, everything is actually passed by value. So when we do this up here, we do set name. We pass an x right here. We'll actually copy everything that's inside of x, like the name. If we had more fields in here, we'd copy everything in there to our function down here as t, and then we'd update the copy. And then when we exit out of there, this x right here is still its original value because it was copied and then updated. So if we actually want to change it, we need to do a pointer to t. So if we run this, hold on, I just have to get in. There's an ampersand as well. Ampersand means address of. So if we have a variable like x, and we want to get, we don't want the value of x, we want the location in memory of where x is. We have to do this ampersand. So we pass that, so we're going to the pointer, or like the memory location, to pass to set name, and then set name can then update that t with name. So now we have Susie. That was a little confusing. But here's another example here. So is this part making sense at all to anyone? Sort of? Okay. So if we actually look at something like, let's do var a int. Okay, so we have a, actually let's do this. A 0. Let's make it 10. And then we have b, oh, by the way, I got the box, I think. Okay, so b is equal to a, and then we'll say is equal to fine. Okay, and then we'll print out a and b. Okay, if we run this, so we're taking 10 and putting it into a. The value of a gets copied over to b. So now b is 10, and then we update a to 20. So b doesn't change because the value is copied into b. Okay. So this is a and b are both type int, just integer. We can change this so that if we do an ampersand of a, actually, before we do that, we'll do. We can actually look at the address of stuff. Okay. So here, if you look down here, this is the memory address, like physically where it is in memory. And you can see that this is a little different than this one right here. It should be about 8 bytes off. Sorry. Yeah. So when we create A right up here, it has a certain place in memory. B has a certain place in memory because we're creating new memory to store like the copy of value or copy of A. Now we can change this. So if we did the ampersand A, so we're actually getting the address of A and putting it into B. So now B is actually, we'll do this, var A int 10. The var B is a pointer to int. So it's going to be a pointer to A. So now if we update A right here, 20. Let's do that actually. So if we print out A and B, we'll get A, which is 20, and then we'll get B, which is going to be the address of A. Here. So we get that address of, but if we do this ampersand thing, so if you're talking about types, so here the asterisk means that it's a pointer to an int. So when you're talking about types, the asterisk means a pointer to. When you talk about the, what's the word? Oh, if you actually have a variable that's a pointer, and you do the asterisk here, it's what's called dereferencing operator. So it means don't give me the address of that, or don't give me the actual value of B, give me the value that the value points to. So like give me the value that this pointer points to, or this memory address points to. So now we get 20 because it's pointing to A. So you get like A and B. B is just here. That's all pointers are. These are just pointers to memory locations. Okay.
And so the memory locations are the same now.
Yeah. Well, yeah. So B stores the memory location of A. So whenever you change A, you can get at it through B because it's a pointer to A. But B actually needs memory to store its. So if we print out A like this, and print out, if we print out B, let's do this. And B. Okay. So if we the address of A, address of B. So address of A and address of B are different because they have to store data. Like B is storing a pointer to A, but it still needs a space to store it. But if you take the value of B instead of the address of, then you can see that the value of B is the memory location of A. This is as hard as it gets, really. What's that?
That's
Yeah. So if you understand that, it should be good.
And the colon equals was just a short form for that.
Yeah, so if you do A colon equals, it just means you want to declare and set the value of a variable. So if you try to do it again later on, like this, then you get an error. So it'll say no new variables on the left side because you can't redeclare the variable, and you can update it like that. You just can't redeclare. So this whole pointer thing, all you have to know is basically the whenever you want to pass something into a function, you want to change that thing to passing, it needs to be a pointer. That's the biggest thing. And in general, I would say that you tend to use just pointers to structures. It just tends to work out easier. So our structure right here, our GitHub event. Oh, sorry, yeah. So back to the question. This T right here is going to be our testing object. And if we look at it, there's a couple functions on here. So I have error. So an error is if you want to fail the test, but you want the test to keep running. I don't use that a lot personally. There's fail, which will just fail. There's nothing. You can't actually pass a message to it. It just marks the test as failed. And then you have fatal down here. Fatal will actually it'll stop the test, some message, and it'll just fail it immediately. Log if you just want to print out a message. You can mark a test to run in parallel. So you have the stuff you can set on the command line when you're testing to say I want to use 4 CPUs. You have to mark them explicitly because a lot of people don't write the tests. If you run in parallel, they'll open up like server ports on the same port over and over again, and they'll kind of stomp on each other. You can skip tests if you haven't implemented something. A lot of times people do like pending. Like they'll write out their tests that they want to implement, and they'll just mark them as pending. So when we're testing on here, we'll take our data that we have here. Usually don't actually test like JSON structures, but we'll just throw it in here for now. So actually, this is kind of a bad example. So let's take our data. We'll make this a string. It's going to be what we can do. We'll do data colon equals, and you can do backticks. So if you have that's a really long test. We'll just take out some of this here. I'll just create this. Actually, no, we'll just make an example here. I'll show you in the play. Let's see if you guys can understand this. So if we have our data, there's a bunch of packages that are built in. There's not, well, I'd say there's not like a crazy number of packages, but you use pretty much all the packages that they have. It's really useful. So if we had data in here, I'm going to dump all this JSON out. So this data right here, we want to see if it'll actually map into our structure. So we'll create a GitHub event here, and then we can say, so JSON, on Marshall, like this. Okay, so create our GitHub event. This is a little shorthand way to create a pointer to a type. Like this will create a new type GitHub event, and this will do a pointer to it. Which we could probably just do. We'll do this actually. So we have unmarshal right here. So unmarshal will take some data, right here. If that casts it to a byte slice. So there's like there's strings in Go, which are just what you think of strings. They're like it's a UTF encoded string. So you have characters, and since it's UTF-8, they can take up like one or more bytes. And there's stuff inside Go to kind of decode that stuff, or you can iterate over your individual characters. So like if you have weird stuff like a snowman, like this guy here, it's like the dumbest website. Like this little character is just a little snowman. So if you wanted to, another playground here, you can have a string here where it's string is equal to snowman. Say a bunch of snowmen, okay? So, oops. Actually, just call it equals. Okay, so I'm going to print this out and run it. I'll print out a bunch of snowmen, okay? So with Go, so the guy that made UTF-8 made Go as well. So like there's a lot of UTF-8 support in here. If you actually look at the underlying bytes, so these, so encodings, so UTF-8 encoding, UTF-8 basically says this byte right here, or these set of bytes, represent this character. Like if you have ASCII characters, you have certain, like an A is represented by the number, a byte of the number like 65 for capital A. And you can look at those underlying bytes. It's a little bit off topic here, but it's good enough. Let me start with a simpler example. So say S is going to be our A, and then we want to print out the bytes for that. Okay, so we can cast it to a byte slice. Byte slice is just an array of bytes. This. So we have 65 right here. So it's just one byte to represent A. So if we did A, B, C, D, E, then it's just each of these numbers represents that character underlying, in ASCII encoding. The difference though is if you have UTF-8 characters, this one character, the snowman here, will represent. Actually, no, we'll do. So this one snowman, because if you only had one byte, like ASCII only uses one byte per character, but you only have 255 values you can put in there, and there's like tens of thousands of characters out there in the world. So to be able to encode all that stuff, they have this fancy algorithm for like doing variable length number of bytes for each character. So this little guy right here, he actually takes up 3 different bytes. So when you're working with strings and byte slices, the difference is that a string is composed of UTF characters. Super off topic. It's composed of UTF-8 characters, which can be multi-byte, whereas a byte slice is just the raw bytes. So come in here, if we had our, let's see, we'll make a byte slice of the snowman. We could actually come in, we could change, say like V, like say we want to change the third byte to 130 instead of 131. Now we can print that out as a string. Create an umbrella instead, apparently. So all kinds of weird things inside of UTF or inside Unicode. So long story short, you have byte slices, you have strings. They seem like they're exactly the same thing. You just kind of cast between them when you need to, but you can get in situations where you have you actually need to iterate over the individual characters. So if you had like a string of, let's say, S is equal to this guy and an umbrella, you can do a for loop. You can say character range over S And you can print out each of those characters. This. Hold on, like this. All right, so it'll iterate over, even though this takes up 6 bytes right here, it'll iterate just twice, okay? It's 1 time per character. Whereas if you had, if you converted this to a byte slice, so individual bytes, it'll iterate 1 byte at a time. So it'll do all 6, okay? This is making sense. It's not super pertinent to what we're doing, but I think it's good to know. All right, so our GitHub stuff right here, we're going to cast a byte slice from our data down here. That, and we're going to put it into our event. So we need a pointer to the event. And this returns an error, so we need to check our errors. So this is like a, you do if statements where you have a simple statement inside. Say this error is equal to the result of this unmarshal. And then we're going to check the error, and if it errored out, then we'll print out the error right here. Otherwise, down here, we'll print out from print, we can say e.id, and we'll do the actor too. Or the type. It'll be actor, how's that? Okay. So that works. Invalid character. Like that guy. Okay. Martian number. Okay, so actually, I guess the test probably would be good for this. So we have some of these in here. You can't cast. Oh, let's go back up. So this this error right here. It's just syntax makes sense to people. I don't know how easy that is. It's the same thing as saying like this. We're going to create an error from this unmarshal. So we're going to take the data in here and basically convert it into, or write it into our GitHub event type. Okay. And then if we can't do that for some reason, we want to have this error is going to return and tell us what's wrong. And if there's something in there, we want to print it out. So there was an error, so print it out down here. But it can't unmarshal a number into a string. So the problem that we have here is that this ID for the actor is a number. Like this first ID is a string, this one's a number. So this actor right here, we need to change that to an int. And this repo ID is also an ID, or int. But the rest of these are all strings. It's a double quoted. I guess, how many of you guys have done JSON? I just realized. What's that? Sort of, okay. No, okay, you haven't gotten that part yet. So JSON is just an encoding to get, like if you have data you want to send to someone else, the system that they're running, like how they store the data, is, yeah, it's jumping quite a bit far ahead. So this GitHub event right here, like in Go, we structure data in memory in a certain way, and in Ruby it'll be stored a different way, and then C or whatever different language you use, it's always kind of, they have their own little flavors of how you store data. So in order for those different systems to communicate, you need to be able to have like an intermediate representation of that structure. So a lot of people choose JSON because you can just look at it and read it. It's called a human readable format. There's a lot of formats too that are binary formats where they're very low level and they're you have to like pull out a hex editor. Like a hex editor looks like it's not a great example. I don't have any data in there. There we go. Hex editor is just like when you have like hello world like that. These are all the underlying characters and numbers that are in there. So the binary ones, they're much faster than human readable ones like JSON, but it's not as easy to debug. So this format here for JSON, you have like an open curly brace, and then you have some fields inside of that. So they just like a key and a value, colon with a colon in between. So we have an ID field, type field, this actor, and then that actor has a little curly brace, so it's kind of like a nested structure. And then you have this is a number because there's no quotes, and you can do arrays in there too, some other stuff. But in general, it's probably the simplest format that's out there. So what we want to do is we want to take this string of data that we're getting from GitHub, we want to convert it into our representation in the memory and go. Okay.
And just by structuring your struct the same as the JSON, that unmarshal is able to just parse it indirectly.
Yeah, if it lines up well, I mean, a lot of times it'll line up pretty well, and you can just have it dump in automatically, which is nice. Sometimes you have to tweak it, and you can actually have it. You can actually override how it marshals the data. And marshalling is just if you marshal data from what's the word? So if you have your in-memory type, if you go structure here, when you say you marshal it, it means that you basically encode it into JSON or into your intermediate format, and then you unmarshal means you go from that intermediate format back into your in-memory format. Sort of, yeah. Makes sense. Do you have a question?
Well, so line 11, I guess it's still,
Hmm.
it's almost like doing like multiple like assignments where it's like setting E and then also an error if one exists.
Oh, sure. Yeah. So you give this you give the unmarshal function the thing you want to encode it into, and then the error. A lot of functions in Go return an error, and you see it. People complain about this a lot, where you see like it returns an error, then you have to check the error and do something with it. That's kind of Go's thing. Is like errors are normal things that happen all the time. You should handle them, and when you handle them, then your programs don't
So
crash.
the return value of most functions is not like the value of what you're working with, but
Well, you can actually, so it can be, this is a little unique in that you're taking data and you're doing something like you're unmarshaling into it. But a lot of times if you have a function like, another little play. If you have like an add function, or A and B, no, that's a really bad example. Let's do a split function. Or here. Okay, so if we have, let's do this. So you can have like a file. If you want to create a file called foo, it's going to return a file handle and an error when you create it. So you have to check the error. You can say font my. Just print out the error. And return from here, and then you can write to that, write to the file here, and whatever code you want to write in there, and you can close it down here. So this the syntax you can do it multiple returns from Go because most Go functions return an error, and you have to handle that error somehow. So if you get past this if statement here, like there's no error when opening the file, then you know that your file is good to use. At that point, you can write to it. So you'll see a lot of multiple returns. They actually do get the value back. The unmarshal is different simply because you have to give it something that you want to encode into. It's not just, you can't just give it the data because the data doesn't have any type to it. It couldn't do this because it doesn't know, unmarshal doesn't know the format or like what type this data should map to. So that's why I have to give it to it. Okay, so E, okay. And okay, so now we have, we can parse out the ID, we can parse out the active login. Those are both right. We can actually, if we want to really look at it, we could marshal it back into JSON. We say JSON marshal E error error. And then you can print out okay, so we're trying to get just a subset of data. So whereas, this whole big thing that we pull in, like we don't get the Gravatar ID or the URL, but we can see here, let's do JSON. You can see the JSON. This is a little formatting website. You can just dump in some JSON and make it pretty. So you can see these are the fields that we have in our structure, and that's what it encoded into, and then we encoded it back out, back into JSON just to see what we had. Does that make sense? A little jumping around there. Okay. Okay, let's just get to data. Let's put some data and do something with it. Okay, so we'll take this out. You know, a lot of times too, we'll just make this a little easier. If you actually don't know what you're doing for your project, you're just kind of winging it. Then a lot of times, we did this last time, it worked better. As I'll start writing the actual program itself, and so like I tend to structure my programs as I structure them as libraries, and then like some like command line application can use that library. I find that like it helps me design code a little better. But a lot of times, instead of just writing one CLI application and just dumping all your code in there, it's easier if you can structure it out as like kind of two parts. We'll just go ahead and make the function or the CLI here. So got our main, got a GitHub event here. Let's change that. So we can get some data in here. So we'll import one package, and inside our main, let's just make sure this will compile. Okay, so when you want to run Go apps, we're in our EDB directory here, and we have more than I wanted. So I created the CMD EDB directory for command line application, and to be able to use that, we can just do go run CMD EDB. Okay, so that'll run and then print go out. Okay, so it's not doing anything too fancy right now, but we will take. Let's get some GitHub data. So go in. Okay, so we want to pull from this URL right here, and we'll just parse out whatever events come through. And if there are push events, well, we'll just print out whatever events we get. So we'll need the HTTP package, so we can call it to that. So we'll do, okay, so HTTP, and we get this URL up here. The response, error, error. There's another package called log. We can just say log fatal on the error, so we'll just die if it doesn't work. So we're going to retrieve. Okay, so the GET, we get a response back, and there hasn't been an error connecting to the server. We can check the response that's on there. Actually, before we do that, we have to you need to make sure that your response body is closed. It's just a thing you got to do. Well, so there's a thing called defer, which just means that you want to run this code right here by the end of your function. Just ensures that it always gets closed. So if you have error, like if you have an if statement here, like if response status code is not like a status okay, like a 200. If you get a response from the server saying that something failed on the server, you want it to exit out and do a return. This defer right here ensures that your close gets called either here or by the end of the function right here.
What's a close?
Close. Close. So when you connect to the server, it'll keep a connection open to stream down all the response from that server. So if you don't close the body of the response, like the response itself, then it'll keep that connection open indefinitely. So you just want to make sure you basically close your connection so your server doesn't fill up with connections. So you can think of it at this point, it's just a convention, just make sure you close. And defer, make sure that always happens. So we get the response, and then we can decode events. Oh, we'll just decode the events. So we're going to create a decoder for JSON. So we can take our encoding JSON package. We'll say JSON new decoder. So decode does the same kind of thing as marshal and unmarshal, but it works on streams. So you can take our response body. It's like if we had a body that came in, and instead of having just one JSON structure, like object in there, it just has one after another indefinitely for all time. We can connect to that and just stream those one at a time and just feed them into our application. So Yeah, so we'll use a streaming one because we already have a response body. Oops. And then we can just loop over these. So we're going to do an infinite loop right here. And we will do, so decode e GitHub event. So we're going to decode into our GitHub event. Okay, so it's taking the stream up from the body, which is this data that's coming in, and for it's going to grab. Looks like it's an array. So it's an array of objects. So we'll do. Actually, this sounds interesting. If it was a stream, we could do it with a decoder where it would stream in constantly. Right now, we just have an array of these. So we'll do called A, or call it events. Events. Okay. Okay, so we have a decoder. We're going to decode it into events. Again, check for the error. If there's an error, then we'll log if there's an error. And now we can go through and we can just print off the events that we got back. So print events. So for loop is kind of overloaded. You can do a couple things. If you have a slice, so slices are just kind of like arrays in most languages. You can take this list here, and you can have the index. You can get the index of it first, and then the element that's in there. You can say range events, and then we'll print off maybe what's going to be in there. We'll just print off the type of event. And then it's going to be type. There's also, so in Ruby, you get all these fancy, like the interpolation thing. We can say, like in Ruby, you could do something like this. So you have the type like that. Go doesn't have that. Most languages really don't have that. They usually use these placeholders. They're kind of ghetto. But the idea is that this placeholder here will match to, like this is the first placeholder, so it will match to the first argument that's after the string. It's not a little thing. If we wanted to number these, you have D for like integers and you have S for strings. So we're going to have this be the index in our loop. So it goes 0, 1, 2, 3, 4, 5. So we can print all those off. This makes sense here. We're just looping over the events, printing them out.
Why are you using the decoder and like close if it's not a stream? Or
if it's not a string, well, the response body is a stream. It'll stream the response body in. We could read the whole body in because this request here ends. It'll just print out whatever it has. It's not a lot of it. Like it prints it out, but it'll stop. Some streams, like sometimes when you connect to a server, it'll just leave the connection open and just stream stuff to you on the fly. So that's why the body is a stream that you have to close. If we wanted to, we could just read all of it in and then unmarshal from that.
So like in this case, you might not need it, but like in general.
Yeah, in general, yeah. So you could do, the other option too is doing, there's a helper called IOUtil, where you can say IOUtil read all on the response body, and that'll actually give you a byte slice back. And then from that, you could do your, if you had your events up here. And you could say error, or you gotta check error on the read all. So here, assume that you have your bytes from that. You can do the JSON unmarshal with your bytes to your events, like that, same as we did before. But yeah, in this case, it's just a little easier, I guess, to do the decoder. So decode the events from the body here, and then we're going to print them out. Oh yeah, so that's the other thing with Go. If you import stuff and you don't use it, or you have variables you don't use, it won't just ignore it. It'll actually error out. From that, okay, hold on. So print line, you actually need to print F. It means print format. That's where you can use these little placeholders. And you need to put in the new line. Like that. Now we can see we get a bunch of events. We get 30 events. You know, push, push, watch, watch, push, create, all this stuff. We can get, there's probably an actor on them. So we can say S by S placeholder. So we can say E actor login. Run it again. Yeah. And we have users that are actually getting those events coming in. Does that make sense? Okay. It's always funny to like see people's names like extra worst or wiggle wag. I don't know. Yeah. This one, like, why do people do that? Freedom of information. Nice. Okay, so we have these events coming in. So we want to take these GitHub events and actually store them somewhere. Oh, let's see. Got them coming in. Here, we'll actually refactor this out so we can actually make this reusable. So we'll create, we'll create a GitHub package to manage GitHub events. So we might have other events in the future. Say GitHub, go, package, GitHub, and then let's take this event out. So one thing you see, like, see a lot of redundancy. Like if you have a package here, say you had like a GitHub, yeah, push event, and you had like a GitHub like commit event. You start seeing GitHub, some prefix over and over and over again. A lot of times that means you probably need your own package for that thing. Like naming, I would say is a big thing in the Go community. Like they're really kind of inattentive about that. So what we can do is we can take this off. It should sound normal, like when you're typing it out. So we have this GitHub package here with our event. If we want to use it from this other package here in our main, so they're two different folders, two different packages, we actually have to import it. So we'll take from our GitHub source path, or our GitHub git path, go path, source, db, and then GitHub. So we can take our event right here. So if this sounds weird, like GitHub.GitHub push event, then you should change the name. They call it a stutter in Go, which is a little bit, I don't know, that's the best name. But you can say GitHub push event like that. Like that sounds much more normal. So if you have a package named GitHub, don't prefix all your stuff with GitHub. So we're going to split this out, and then we'll have us push event, just an event.
Packages are lowercase.
Yeah, in general, you can do them uppercase, but you'll probably get just derided if you do that. In general, the lowercase, don't do, like some people will do hyphens, where they'll make like a package like, I don't know, they'll say like Go GitHub, stuff like that. Don't put Go in there, because it's a Go package. It has to be. And don't put hyphens in there. It's usually one name, short. Another thing too is if you're using it, when you import this package, you have to import the full path, but you just use the last name of it. So if this is a really long name, then it's a pain just to write constantly over and over. Okay, so I got decode events. So let's actually pull this retrieval stuff out. Go here, save an event, and we'll say events. We'll get a list of events. Okay, so our function events, translate this out events from GitHub.
What's that array at the front of it?
What's that?
What's that array? Yeah.
Oh, this one. Oh, so that's the return that we're going to get back from this function here, events. So we're going to get a slice of events back. It's kind of weird naming. I suppose we could actually make like a client or something, client type. So you can make, I'll show you. Events, we'll make this C. So you can do what's called a receiver on your functions. So these are basically methods on the client. You can have structured nothing too. So client connects to GitHub. Okay, so this client right here is a receiver of a function, events. So whenever we call events on a client, then we'll call this function and pass in the thing that we're calling on. And then it's going to return events and an error. Okay. So when we call that, so we'll need a client, GitHub client, and now we can call C events like this and get back events on the array, check the error. Events. Okay, so now in our GitHub right here, okay, we're retrieving from the stream, just this URL. When you're inside a library, typically you don't like kill your program. Like if you get an error, you want to keep passing, kind of want to keep passing errors back up until someone can do something with it. And when you get like in our main program right here, this is our CLI. Like the main function is the last place. There's nowhere you can't return anywhere from main because it's your main function. So that's why we do a fatal right here and just kill the program. Whereas right here, we can just pass it back. So we can just say return error. And then here, if we get a decode error, we can say return error. Okay. And then we'll return nil. Sorry, hold on a second there. Okay, this should be nil. So we don't have a list of events. Our first one here. And here will be nil.
Yeah, I suppose that would return two things since it's a fixed string.
Yeah. You can do named one as well, named functions like func foo and return like a int and b int like this. You can actually set a and b's 20 and just say return, and we'll return. Hold on, let's say xy foo x y. Okay, so here you can actually set, if you name them here, it essentially declares them and then just sets them to like what's called a zero value. So if you didn't set one of these, it gets initialized to 0. So when you run that, it'll return zeros or be 0.
Because it's an int?
Because it's an int, yeah. So there's,
straight.
yeah. So there's always a 0 value. So like if it's a pointer to something, the pointer is just a null pointer, so it points to nothing. Like if we did, let's say var pointer is a pointer to an int, and we print it out. Let's do this. Print out pointer, it's just going to do this. No, nothing. So if you actually tried to access the pointer, like try to do pointer plus 10, this might not work actually. If you dereference it first, then it'll do a panic. It basically crashes the system and says there's an invalid memory address or null pointer.
I'm assuming the error is always the last thing returned?
That's a convention, yeah. I guess you don't have to, but we'll look at the read otherwise. Okay, so we have.
Walk through the client one more time. Like,
Oh, sure. Why do a client? So actually a couple reasons. So on the client here, it gives you a namespace to put things in. So like before we could just do it like this, events, and then we just call, it would just be GitHub events like this. It's on the function is on the package. The downside to that, there's two downsides I can think of. For one thing is that if you ever wanted to have a type that's a list of events called events like that, you want it to be a slice of events like that. Oops, event. If you had that in the namespace, like the global namespace, these would conflict. So you can't have a function name events and a type name events. That's one problem. The other problem too is that if you want to mock out these event, or like the client, so like if you want to make a test for GitHub, oops, new file, let's go. You can mock out stuff inside your client. So say you wanted to do, so you have just like a URL you wanna access. Okay, we'll do. We'll say if C URL is not blank, let's set it to C is equal to this. Sometimes you want to mock out stuff. A lot of times you want to mock out stuff in your tests. So over here, we had a function test client events testing to. In Go, you can actually fire up and so you can actually fire up a test server just on the fly and kill it. It's pretty fast. You can say new server and actually put a handler in here to essentially mock out like the GitHub server. So your client would then call this internal like test server and it will return a response, and you can fake out the GitHub server. And that's where you change your client URL instead of this default API, and you can set it to whatever your local host or your local server is going to be. And this thing's actually pretty cool because it'll do it'll pick a random port on your machine and just fire it up against that. So you can actually run your test in parallel, even though you have stuff running on servers. Yeah, that's a cool window. HTTP test is a good one. Okay, does that make sense?
Yeah.
Okay, check that off. Let's take this off. I'm rocking right now. Right. Okay, so got the events right here. You got some other questions? No, it's early. Great. Okay, so we're decoding events out from the response, and then we're going to pass those events back. Printing those out still. Let's go ahead and test that. Okay, so it's going to tell us stuff like packages we didn't import that we can't find HTTP inside of GitHub right here because we never imported it. So if we add an import on there, so that error goes away. Now it's missing this GitHub one, which we're inside the GitHub package, so we don't need that prefix. We take that out, and now we're missing JSON. So just gotta import that. Okay, and now we have errors on the main. So we're using those packages that we took out. Coding, got that. Okay, I get those, same thing again. But we have it a little cleaner because it's in its own little package there. Okay. Should we copy? Okay, so we have events coming in. We have client. Okay, so we need to store the data somewhere locally. There's different ways you can store it. You could use like we covered the SQL package last week. It's like for accessing SQL databases. SQL databases are kind of overkill for a lot of things, especially simple little things like this. So we used a key value store called Bolt, which is I'll pull it up here. So this is GoDoc. So GoDoc is just like package documentation. And in the Go world in general, people tend to put all their documentation like inside of GoDocs, so they write it inline in their code, and this gets generated from the code here. So there's another nice thing where you can put examples into your code, and it'll automatically generate those into your GoDocs. But these examples actually get run and executed. So like any example you see in a GoDoc should always work because they're executed on the in your test suite. So Go is this database where we have it's just like a single file on your system, and you can open it up, and you can run against it and update it, and you can have basically read-only transactions, write transactions. You can create these things called buckets inside of there. They're kind of like tables, and you have kind of a key value space inside of that. Okay, so we want to create a database that's going to store our events from GitHub, probably by by user maybe. Yeah, we'll store events by user. We can just have a list of all their events over time. Okay, makes sense. So we'll create a database. Let's see here. You know what? We'll just do it. Okay. So import default, and then we'll have a database type. Actually, let's do it here in the main first. So I'm going to retrieve these events. Okay, let's do this. Okay, so first we'll open up our database here. Let's call it data. Mode. So the mode right here, file modes, like if you look at permissions, files, this stuff right here, just a little bit of a tangent. These stand for read, write, execute on here. There's 3 different groups, okay? So you have your user permissions, your group permissions, and your role permissions. So this is what the user that owns the file can do. So in here, this is my name. This is the group that I'm in. I don't know, it's called staff. But it's these are permissions for the user, which is me, the group, which is staff, and the role, which is just anybody that's not in those 2, like in either that user or that group. So when we set permissions on our files, this stuff gets mapped to like an octal number. This is a little bit out there. You probably don't need to know this right now. Just know that when you're setting modes, this just means to let people read it and write it. Probably all you need to know for right now. And then we'll do nil for this. Okay.
What's that first 0?
What's that?
It's 4 digits instead of 3.
The 0 just means that it's an octal number.
Oh, okay. And
then each of these is the user, group, and world. And they're bit flags, if you're curious. It's like there's 3 binary digits in there. Each one of those binary digits is a flag for the read, write, and execute. Okay, so there's an error, opening our data file, then we'll do fatal. And then we want to make sure the database is closed, so we'll defer it. Okay. So open our database.
And what's the nil you're passing in there?
What's that? Oh, nil. Nil just is like the same thing as, I think it's null, or what is it in?
Oh, but yeah, but what do you?
Oh, sorry, yeah. Yeah, it's an options set or thing here. So you can actually do both options. You can do a timeout, set the file. So only one process can actually access the file at once. So if you wanted it to, you could have a timeout after like 1 second, like that. All right, so we'll check that out. So it'll actually hang indefinitely. We can't get to it now. So close, do events from GitHub. Okay, so we want to take this database and we're going to, okay, so function called yes. Okay. So inside of update, so you can do an update, or you can do a view. And this is an anonymous function inside of here. Just means this thing will get run inside this transaction. So transactions are, it's like a consistent state of the database. So like when you go into an update transaction, only one update transaction can exist at a time, both. But it will write, when you start writing stuff and reading stuff out of there, there's a fixed view of what the data looks like at that point in time when the transaction starts. If you return an error from this function, any of the changes you made up to that point when you return an error will actually all get rolled back and will be the state it was before. So you can never have like half of a transaction commit. That's kind of what a transaction means. It's kind of all or nothing. And then there's a view one as well. And view is just when you start the transaction, all the data will be that kind of that same state for as long as that transaction is open. So even if someone else is writing and updating the data, inside of there, the view for that one particular transaction will still see the same thing. Does that make sense? That was a bit of a, okay, yeah. Okay, so we're going to create some buckets, or a bucket. So we'll do create bucket if not exists. And the buckets are just, they just have like a key for the name. So we'll create a name of, what are these? We'll call them users. Okay, so we're just going to have, let's do it. Yeah, let's do events. Okay, so we're going to have an events bucket that's going to store a bucket inside of that for each user that we have. And then each user is going to have its kind of list of events. Okay.
A bucket kind of like a table?
Yeah, it's a lot like a table. Whereas, so a table you'll have like rows that have like an ID and then a list of columns. In a bucket you just have, it's like a key value space. So you can only have one unique key inside that bucket. So if you want to map an ID to that key, or you want to map like the user's name to that key, you can do that. So we're going to create that. Actually pull this down below the events. Okay, so we want to go through store events and database. Okay, so we're going to loop over the events. So I'm going to create a bucket here. You can get an error from this, but it's only if you like don't pass in a name. So just ignore it. Okay, so we're going to loop over the events, and we want to store the events inside this bucket. Okay. So for now, we'll just stick the buckets in, not by user, but just by let's see, we can store them by time maybe. Let's see here. I never grabbed the time. Hold on. There we go. Created that. That's what we want. Okay, so we have a created timestamp on here. We'll throw into created at time.time, and then it will be JSON created. Okay. Right? No. Yes. There we go. Okay. For this field, it's going to get parsed out. I'm going to grab the time. And then we can use this time as our key inside of our events. That's kind of assuming that there's not overlapping times. Let's see. No, it will have overlapping times. Let's see here. An ID. I guess the ID is incrementing. Let's see. Okay, so this one's 980. Okay, so we do have an ID. I'm just trying to find something we can use to store in there as a unique key. So if we go in, oh, that's the wrong file. Yeah, main file. Okay, so we have our bucket for events. We're going to loop over, and we want to store. Let's see here. We want to take your. Okay, so we want to store stuff into a database. Again, you have to marshal that into a format. Well, we can just use JSON because it's already set up for that. But a lot of times you use some like lower level binary format. That's a little faster. So we'll do. We'll just name this bucket here. We'll do JSON marshal our single event. Error, no, error. Okay, so loop over events and insert event JSON, and then insert event. Okay, so we can take our bucket and do a put. So put just takes a key and a value, and if you can't put it in there for some reason, then it'll error out. I think you can error out if you just pass like a nil, the key. There's a couple other reasons why, but we'll do a to the event. What we're going to do, the ID, and then pass the value here, which is this byte slice. If we get an error, return the error, And then down here, we can return nil. If we got through all the events, inserted them all in, no errors, we'll return back. And then, yeah, then it'll commit that to the update. Okay.
That update is a function from that bolt.
Yeah, from the database. And that just means that it'll, if you did a view in here and try to do a put, then it would error. This would error out actually right here. It's a read-only transaction.
So what's it putting in there? It's putting in the event ID
and then we're marching the event back into JSON. We'll probably change the format later.
Okay. The full event as JSON.
Yeah.
Okay.
So whatever we got in and we parsed out, we're going to stick it back in the database. So let's run this to see if it works. Probably won't actually show anything. If we're missing time up here. Yeah, so I made a program. My workflow is that whenever I write code, I run stuff, and then I just look at the first error and see whatever file name is, and then go there. So instead of actually looking or copying this out every time and doing Control-C, I made this program called Goo, which is passes through everything to the go command, and then when it streams it back out, it'll try to match on a file, colon, and then a number. If it finds that, then it'll copy it to the clipboard and bold it for me. And I can just switch over to Sublime and paste it right in. So just being lazy. So oh yeah, so it's saying it's missing time right here. So we didn't import that. It's time with another package.
And you also have it make the first error bold so that you.
Oh, just so I can see it, yeah. I'm trying to do a lot of weird little workflow stuff like that. Little
What was that
background.
for? I missed the beginning of that.
Oh, yeah. So I do weird time boxing things where like I have to know how my time progresses throughout the day. It helps me just keep track of things. And so I made this app called Boxer that runs in the background, and it splits up my time. I'll show you that little. A little configuration here. Okay, so every 15 minutes, you can see it blinking up here too. So there's a couple different little module things in here, I guess. There's a wallpaper, so every 15 minutes, like for every minute in a 15-minute interval, it'll kind of step down every minute, and then when it gets to 15 minutes, it'll start back over. And this is the background and foreground color. And then, yeah, so the menu bar flashes every 30 minutes. I get a little pop-up every hour over here saying it's been an hour. And then, I don't know if I told you this, but I got like a little USB light. So it pops in, and it's programmable. Yeah, so every 30 minutes it'll blink red.
Nice.
I'm just mostly playing around at this point. So I have that running in the background. And if you ever feel like using it, you could just use Go, and you do Go install Johnson Boxer / and triple dot. If you run that, then you'll get a program called Boxer on your computer. You just run it from there. And it's got a little. This is actually the most annoying part. Is launch agents, and on the Mac are this weird plist format. If you ever look at plist, it's like the most ungodly, horrible format. It's like they saw XML and they're like, "Oh God, this is awesome. Let me just totally misuse it." So they have almost all XML you ever look at. This is okay. So this is another encoding format. So you have JSON, and XML came out in the 90s, and people were like, "Oh yeah, this is so much better than binary formats because we can read it," and then I don't know, it's awesome, whatnot. XML are these tags. It's like HTML basically, but it's for data. So you have tags, and you can nest those. And then a lot of times people will do XML where it's I don't know, some kind of data you have in there. Data. And then you have some kind of key, maybe your name. Here, let's call this person here. Person, and the name, and then it's Bob in there, okay? And it's oh, it's kind of cool. And then this kind of thing would map to JSON where you have name is Bob, like that. It's the same thing, okay? It's just different encodings. But with plist, for some reason, they were like, you know what? Well, screw this. We'll call this key. Oh yeah, so they named the key name, and then they have the value here is Bob. Oh my God, it's this is the worst thing to try to parse through because you have to find the key, and then you have to read the next one and find it, whatever. Just know that they're like the bane of my existence whenever I have to do this. So here, yeah, that's where you see like key, string, key array. It's like key value pairs. It's terrible. But anyway, this is, if you ever get into this, plist or this launch control thing, is if you want to have stuff running in the background on your Mac. You can set it up and say, like, this is the program to run, this is what to pass into it, it's my configuration.
The Boolean.
Yes, but yes, exactly. And then, yeah, like who you want it to run as, you want it to fire up when your computer starts up. Keep alive means that if it crashes, then it'll just restart it. So anyway, that's kind of an aside. So yeah, that's what the little kickdown thing is. Does that annoy people? I'm curious. Like, I like it personally, but I wonder if people just can't get past it.
I think the bar at the top goes a little too long for me.
Yeah, you know, I was doing it shorter at first. So I do this thing too. It's totally a tangent. You do this thing, like a lot of people do time boxing, where they'll think like, hey, what am I going to do for the next 30 minutes? And then I want to try to complete this task in 30 minutes. But I can't plan ahead very well, and things pop up and whatever. So what I do is I do it like reverse, where every 30 minutes I try to write down what I just did, just so I can keep track during the day. And it's more just kind of keeps me sane to like know what I'm doing, because otherwise I get to the end of the day and I have no idea. So like before I just had to blink a couple times and I would like just not notice it or ignore it. So now it's annoying enough that I'm like, oh, I should write that down. That's my goal.
So we've been preventing him from writing, basically. What?
Lose it.
So I think if I could get enough shit going on at the same time, just blinking and whatnot, ticking down,
I think
I'll do
it
it.
turned out well.
Yeah, thanks. Yeah, I should have brought the little light in. It's pretty awesome. It's super programmable too, because you can like transition between colors and like,
That's cool.
yeah, it's super nerdy. Okay, so where are we at? Okay, we got our events here. Oh yeah, so in our main program here. So this update here, we're getting our events coming in, loop over events and search. We're back to JSON. Marshall. Okay, so we're putting in our events. Okay, we'll return this. So let's try to get this to actually compile and run. Oh, that's the other thing too. When you run Go or Goo, when you run Go, Go run, it actually compiles your whole application into a binary, like a temporary location, and runs that. So you get all this type checking from that, like in Ruby land. Like you don't know the stuff is broken until you actually execute over that code and it fails. Whereas in Go, you get all the type checking because it actually has to link up the types and compile it into code. So you are not using the function package on main, so take that out. And then undefined JSON, so we didn't import JSON. I declared not used. So down here, since we're not printing out anymore, if you have a variable that's being set, like in a multiple assignment situation like this, if you're not using, you can just do an underscore to mark it as unused. Okay, so that ran, and now we have our database right here. There's a minimum size on it, that's why it's so large. So it'll just create like a 1 megabyte file, and it'll grow it as it grows later on. But we can take this, and then since we started in there once, what's that? Oh, there's a cut making noise. Let's call this function load. Let's make another function to read from that, just so we can test it out. We'll move this to a different package, refactor it in a second. Let's do read. Or DB, how about that? Okay, so call print DB instead now. Okay, so in here, we're gonna let's open our database. Here in main, pass the database here. So bolt DB. And bolt. Okay, so I'm not calling load. It's already load because we already loaded. We already have, just to check it. So instead of doing an update now, we're going to read them out in a view. Read only. We're not going to change anything. And then we know this bucket's created. That's the first thing we did. So we can just say bucket is equal to create bucket. Okay, so just grab the bucket like that, and then we can loop over the stuff in there. So with Bolt, like with what's the word? Like SQL databases, a lot of times you'll execute SQL queries, and that will kind of take your data and kind of smash it together in the format that you want it to, and it'll return it back to you. If you're using key value stores, a lot of times they're more low level. Like they'll just say like, I want to get this key, or I want to go to this bucket and I want to go through the keys, or I want to seek to the certain key and then iterate over from there. So to iterate over keys inside of here and inside of a bucket, you have to create a cursor. So create bucket cursor, and then we can do a loop on there by doing for loop. So let's say for kv, oops, c first. I missed it 1 second. K is not nil. K, B, C, next. Okay, so this is going to start from the first key and loop over until we get to no keys at all. Okay, so it's going to start off, this is like the for function, like you see like a for I, 0, I is less than 10, I plus plus. There's names for all these little sections, but I don't know what they are off the top of my head. This is the initializer at least. This is the initializer right here. So it's going to start, it's called once when the loop first starts. This is the conditional, so it's going to get checked on every iteration of the loop. And then this is the do or something. I don't know what this one's called, but it's some code that executes on every loop. Okay, so here we do the same thing as this kind of loop, this 0 through 10, except here we take the cursor and first thing we do when we come into the loop is we position it at the first key and value, and then on every loop inside of there, it's going to check this condition to make sure that we got a key out of there. So if there's no keys in there initially, it's going to call first. K is going to be nil because there's nothing in there, and then it's going to see it's nil and then exit out. Okay, but if we have something, then it'll execute the first one, and then it'll call this on the next iteration. So it'll overwrite those first key value pairs, or that first key value pair, KV, with the next key value, and then it'll check to see if that's nil. If it's not, then it'll execute the body and just keep iterating on that until there's no more left. Okay. Great, so we're going to loop over, and here we can just do, we'll just print out what we have. It's the easiest thing to do. So let's do string k, it's going to be equal to string v. And dump out a bunch of stuff. Oops. Missing return the end function. So this view right here also takes an error, same format as the update. It can't roll back because it's view only or read only, but it just matches the same signature. That's a lot of data. Okay. To put another new line in there. Okay, so let's read from the database. We can see in that bucket we have a key, which is the ID, and then we have the data that's in there. And even though, like when we got the data in, it starts from the most recent events and goes to the older events when we stream in. When you put it into Bolt, then everything is sorted inside of a bucket by the key. So here it starts out at the lowest key and goes up. And that's always, and yeah, it's always sorted in that way, which makes it nice. Like if you have stuff that's ordered, and you're doing like range scans. So a range scan is when you start at one point and just iterate over each consecutive value. It's really fast for that kind of stuff. So if you're doing stuff like our event database, where we want to get at one event at the beginning or at some point in time and go through to another point in time, it's efficient for that. Okay, so we got the ID, and this is kind of the blob of data we have as the value for each one of those. So if we want to pull this stuff out, then we need to do, we need to actually decode it. So let's see here. So we'll do the same kind of decode. So our event, GitHub, oops, event, and we'll say if error JSON Marshall from V into our event error. Okay, so now when we print out, we can actually do re dot, what was it? We have an actor name, maybe? Something like that. No, login. That's what it is. Okay, so now we're actually getting that data from the database. Is this, I guess, following so far? Okay. So we're getting the data from the database. We're decoding it. We're unmarshalling back from that JSON that we had it stored as into our in-memory object. So again, it's like anytime you have to take your in-memory objects and convert them, like either send them over across a network, or you have to store them in a database, or that kind of thing, you always have to convert it to some kind of byte representation, which is the marshalling. So we got this stuff now. We might want to make this a little, okay, let's clean this up. So right now everything's in our main function. It's getting kind of ugly. So we'll go back, yeah, we'll go to here. So we're gonna make this type DB, or DB type. It's gonna wrap our Bolt database. So it's kind of like an application layer type or level type. So like this DB type will kind of know about our event database, whereas like Bolt just knows about keys and values and buckets, and like it doesn't have any sense of what our database is trying to do. So it's kind of this application layer versus kind of like storage layer types. So we'll do a Bolt database inside of that. DB that represents. Let me make sure Will's not like asking something. Okay. Is he on there? Hey, Will. All right, he can't say anything, I guess. On there. I don't think it ever came on. What's that? Oh. I lost. Okay, well. Okay, so we're going to have our application layer or level database. So it's going to represent the application database. And we'll do an open on there, path. And this is just going to do, hold on, DB. So we're just going to do that same Bolt open. We already have a DB. This is already called DB, so I just call this D. And then return the error if it fails. From there. And then here we'll do D. Okay, so what we have. Okay, so this open function on the database, we just want to be able to open the underlying Bolt database, which we have a little reference to right here. So we do the Bolt open, and then we call, if it errors, and we return it. If it doesn't, then we're going to assign that Bolt database to the DB property on our database, okay? So we have, it's kind of that whole application layer versus storage layer, okay? So make a little close on there to wrap the Bolt database. Close. Okay, so close is just going to close the underlying Bolt database. Always put Godocs on there too, even if they were done it, I think. Let's open under data. And close. So we're going to take our functions here. We have our update. And we're going to stick it in here. So we can say save events. Stores events in the database. Okay, so one tricky part about Go that takes some getting used to, but it's actually really good, is that you can't have typical dependencies. So you can't have one package depend on another one and that package depend on that first one. You can do that in Ruby and most languages, but it kind of makes things a mess. So we can't, like if we want our GitHub package here to reference EDB, for some reason we can't have EDB reference GitHub. And also, which is, you know, like we did this kind of thing here, and then reference it in here, like if we had something in here that said, you know, EDB, DB like this, like if we're trying to use the database, we can't do that. Just okay, you have a cyclical dependency. So we can take, so what we actually probably want to do is, so we have database, or we have events coming in from GitHub, but we want to normalize, like we kind of want to normalize our events to some consistent format that it's specific to our database, because we might want to pull in like Twitter events, or we might pull in, I don't know, if we have anything, like if we had like a Raspberry Pi here that had some sensor on it for like when people came in the room. I don't know, whatever you guys want to do. What's that? Oh, nice, yeah. Or if you like want to have like a big red button, like you could hit it or something whenever you want to do something. Like if you want to normalize all your events, it's good to just have like one single event type and just have this GitHub stuff here kind of be an interface between GitHub and your system, really. So we'll do that. We'll make an event type for EDB. You gotta find a better name than that. Okay, so our event is going to have an ID, JSON. It's going to have a username maybe, or yeah, sure.
Yeah.
Sure. Username probably makes more sense. User. Type on there. String. JSON. What was there?
Username login, are you referring still back to the GitHub stuff? Or
username? Yeah, it'll map over to login, actor.login. Like, there's a lot of stuff we really don't need. Like, we really don't kind of care about the actor ID. I guess we could have a user ID. Repo. Like, we kind of want to genericize, or make it generic. What's that? Try genericize.
Genericize.
Okay, we'll just take the there. Maybe we'll just call it like target or something. I don't know. It's the thing that you're doing something to. We'll just make it string. You can put whatever you want in there. Okay, so this event returns a genericized event. I think that's a word. Okay, username type. Okay, so we need to take this GitHub stuff here and we're going to convert it to our types. And actually, before we do that, we'll make this. So this takes events now. List of events. Okay, so the update actually returns an error. We should be checking that, but here we can just return it. And then, like one way you can get an error for update is if you closed your database and then you called update, close database. It will return just error closed. Okay, so we're going to create the data. Let's create the bucket. So one thing here, like we can do this create if not exists. It's nice too if you do that when you initialize up here. So like qb update tx bolt x error. Okay, initialize top all buckets. Okay, here we can just create it one time, and we know that like this open gets called first before anything else, so that down here we can just reference the bucket without worrying about whether we need to create it or not. Okay, so now we can say bucket events. I got loop over events and insert. Go to events, Marshall, error, put. Bucket. We're going to insert into the bucket same way, return nil. Okay, so now we have a save events. So like we don't necessarily want our app or CLI application to have to know anything about Bolt. Right here, we really just want to use the database we have in our system. So we'll do, so if we have a var db, what is it called? edb, db, a lot of dbs. No, we'll just do, here, we'll do this actually. We'll do db and create a new function on here. A lot of times you'll need to create a constructor like this for your types because I don't know, you want to initialize something on there. So we'll just, but here this doesn't need it yet. So we'll just make db like this. Here. And okay, so we have a db, and we're going to do if there open our database. No, then we can do log fatal. Okay, then we got to close. Now we're saving in. Let's load here. We'll do pass in db, edb, edb, save. That's if error. Oops. Okay. Now we have our type, our save events, and we're still getting like GitHub events back from the client. We need to change these GitHub events and normalize into our regular events here. So we'll take events and make this type in GitHub. We'll make it different. So this GitHub event here. So in Go you have what's called exported types or exported fields and non-exported fields. So if you want to be able to access something in a different package, so like when we do like this edb.db, it's horrible. Can't stand saying that. The only way that we can use this from the main package up here, into this other package here, is if it's uppercase. So that means uppercase first letter means that it's exported. If we had a DB like that, we wouldn't be able to get to it. So it's basically like private versus public. So in our GitHub right here, we don't necessarily want to expose the event. We can just make that little event. These types need to be uppercase because the JSON marshaller needs to look at those, and it can only look at the exported types. We can come through here. We'll decode the events. Well, we'll do. Okay. So we want to return a type edb event. GitHub Johnson. Okay, retrieve stream, decode events, response body. Okay, so we want to go through and a lot of times slices are just named A, just kind of a dumb name. If they're not used like in a large context, or like if it's really localized, it's just really brief. A lot of times it'll just be abbreviated short letters. We can take this, like that. Okay. We're going to decode our response body into our local type of event here, and then convert GitHub events to edb events. So now, and then we'll take it down here. We'll call this edb event. We can go for e range a. Okay, so we want to create a new GitHub or like an edb event from our like a generic edb event from our specific GitHub event. So we're just going to map that over. So we can create a structure. Let's see here. I'm gonna find a different name. Do close GitHub event. And then this will be our edb event. So this one we just need to map over from these right here. So we've got colons on there. Commas on there. Oh, the other thing too, if you see the code jumping around, there's a thing called GoFunct. I'll show you this. Okay. So there's like a built-in formatter for Go. Like there's only one way to format Go code, and it's like that's what everyone does. So if you try to do stuff like, for example, here, if you try to do if 1 is less than, I don't know, this is going to work. Or here's a better example. Let's say if 2 is greater than 1, and we'll print this. Should always be greater than 1. But like stuff like this format right here. Oh, that actually doesn't work. Damn it. Try doing here, like if you had parentheses around 2, 1 is less than 2. Like you don't use parentheses in your if statement unless you have like multiple groups. So if you do format, it'll actually take those out for you and simplify that. If you do stuff like multiple lines or like don't have right indentation when you do format, it'll automatically just do only one single blank line, format it out. So that's what the formatting stuff is. Okay, so we're going to map over from our GitHub event ID to our type. Our type is going to be, I don't know. We'll just use GitHub event type. And we'll do username, GitHub, actor, login, and our target is going to be, we'll just call it the repo. URL. Okay. Here's our format now for our event, and then whenever you have slices work in this weird way. Instead of an event, like in Ruby, you can push stuff onto the end of an array. In Go, you actually have to use this thing called append, and you have to assign the append back to the value of the slice to make more sense once I actually show you. If you want to actually put something at the end of events, that does go for a long time. You need to do this. So we're going to push E on the end of events, and then return back kind of that new slice. So the way Go allocates memory is that it takes up like a certain chunk of memory. Here. This is how slices work. So you have here are our events, slice of events, this event, and you basically have like a slice or a slot, for each one of those events on our slice. Okay, and there's two different variables, like two different fields on a slice. There's a length and there's a capacity. Okay, so your length is the number of elements that are in your slice, and your capacity is how large your slice is, like how many it could hold. So when you start off and you don't have anything in there. Okay, actually start off you have like a nil slice. Okay, actually blank. It hasn't allocated any memory yet. As soon as you put something in there, if you append onto the slice, so you do your events equals append events, E. So you put 1 in there, it'll create, this is nil, it'll create a new slice, and then put this in there and return that back to here. Okay, so you're overwriting. So now you have a slice that has 1 in there, okay? So your length is 1, your capacity is 1, okay? Next time you try to append on there, and it doesn't have any more capacity on this one here, so it actually has to reallocate, it has to allocate new memory and copy over your existing values over to that new place. So it actually creates a copy and then essentially just kills this old one. But this new copy is going to be larger, okay? So it's going to have like some extra spaces. So let's say like 4 spaces. Okay, so now it's larger, it has a capacity of 4, and it's tacked on an extra, that append you just did. So now next time you append onto here, it doesn't have to reallocate memory, which takes a lot of time. It can just keep appending on. So you're growing this, you're getting 3, 4. Once it gets up to the capacity again, and you try to append on, it actually has to reallocate somewhere else with extra capacity. Usually like doubles it up, and then it'll copy it over and delete that, and then you get the kind of a pointer to that new location. So it's more of like an optimization. You can do this kind of stuff in C, where you have to manage your own memory, but with Go, they kind of do it for you. But because of that, you have to have this weird syntax of append this thing and this other thing and return this new thing. Okay, so we're appending, creating the events. You guys need to take a break. I've been going for like 2 hours. Okay. Yeah. Yeah, once you get data in the database, you can actually do something with it. It's more interesting. Yeah, what are you guys doing for a week off? Anything? Yeah.
Still got 6 months left.
Yeah.
Gain of 6 weeks.
It's your job hunting, huh?
Well, yeah, I'm starting to.
Yeah, how's the job stuff going for that previous one?
From what it sounds like, it's good. They're a little more optimistic.
That's good.
Yeah, like things are turning around quite a bit.
Oh, okay.
The first couple were just like hard time of year.
Oh, yeah.
So, but there's a job fair tomorrow
Oh, cool.
here. They're expecting more employers than people. Then
Oh, that's cool.
next expected. So hopefully that goes well. I guess Jeff's been working a lot on that. So
Nice, yeah. Yeah, he's on that stuff pretty well.
yeah. We'll see. I think this would be like the real tell. This cohort graduated.
Yeah.
Maybe the one that just graduated too.
Yeah. Oh, man.
Okay, let's see. Line 17.
Mhm.
Saying you're assigning multiple things there, response in the error,
Mhm.
checking the error. Then on line like 25, because that's not actually returning anything. It's like decoding into A, right? It's like
Yeah.
then that if something is returned, then it's the error, right? That's
Yeah.
why we're just if error instead of.
Yeah, and the decoder here. What's so you're using that? Yeah. So the way the decoder works, it's really nice to practice. Like,
So tiny.
yeah. So the decoder, or there's a thing with Go. There's readers and writers are like a big thing, and all they are cover interfaces. But so like readers and writers. Okay, so readers. So we talked about interfaces before. Okay, so interface is just any type, like you can. An interface is a type that just specifies a list of what's the word, functions that a type has to implement. So like reader has a read function, okay, and the writer has a write function, and it takes like each of these takes like a byte slice and returns the number of bytes read and an error. Okay. Okay. So like anytime if you implement a type that has a read with this exact signature on it, then it can be used anywhere a reader is specified. Okay. So this read right here, you pass in a byte slice because it's a buffer, so you can just keep reusing your buffer instead of allocating memory. But the whole thing is the readers, you can use them like files are readers, network streams are readers. There's just all kinds of things that can be readers. You can like nest readers inside of readers, so that you can have like a file reader. The file can be put into like a gzip reader, so you can actually un-gzip the file as you're streaming it out. You can do all kinds of cool little things. So this reader right here, if you pass a reader into the decoder, JSON decoder, you pass that reader in. So in our case, it's the response body. So that just implements that read function, the response body. So decoder will just keep basically reading in from whatever the reader is. And every time you call like a dot decode,
So it's like,
something like your you're gonna set array right there. So we just maybe there's a string of events, okay? So we just want to pass in this an E, that one event. It'll read out that next JSON object and put it into E. If you had a bunch of them, so you do like your curly brace and then ID and whatnot, like that. Curly brace and then have the next one, ID. Curly brace. Every time you call decode, it'll basically decode the next one, the next one, the next one. So if we wanted to connect up to a server and have it just stream down one of these after another, we could just put, create one decoder on that reader, and just keep calling decode one after another, until the connection fails or whatnot. So it's really around, like you're working with streams, it's nice to be able to just create this decoder once and then runs the reader. Or like if you wanted to have, again, like a gzip reader, you have
the actual
reader. So you can write your response body, and then this reader reads from this guy, this one reads from that. It's kind of like this hop thing, where it reads from that, and that reads from that. And keep that in as Jesus, if you said you could do that, whatever. Don't do that. Does that make sense?
Yeah, so I'll do that one. It's just
Why does that have to be connected?
well, because I'm going to do an Angular for it. It's really different.
Okay, so we have events. Okay, I'm just trying to normalize the events coming out. I got this normalized. So yeah, our GitHub package right here is just an interface to the GitHub world that then we can push into our database here. Remember where we're at. Okay, so we have updates undefined. So UV update. It's being called on DB. You can call it on DBDB. There's one else also DBDB. And then our variables on line 27. We're trying to assign to, if you have like an empty, like an unused variable, you can't assign to unused variables. Let's take that out. JSON's undefined. Code and JSON. And then can't convert ID for. Because E of an integer on the register. Okay. Now back to the main. So we need to import DB. Okay, DB view. Oh, okay. So right here. So because the database, the underlying database is unexported inside of here, it's lowercase. If this is uppercase, then we could use it outside of here, but we kind of want to close it off and just have everything go through the methods that we have on our DB. We need to move this inside and make a nicer function. Like, call it events, maybe. Events. And maybe this stuff. So we want here. Okay, so for our events, one tricky thing here is that our events, we're using a nested function here, or a anonymous function. So we can't we can return an error out of this function, but we need to declare the events we want to return above it. It's a little weird. That makes sense, maybe. Yeah, so this event here needs to get returned at the bottom. Like that. And then we'll do bucket. Let's see here. Events cursor. Events. And Marshall. Okay, now we want to do events append events E. So we're going through each one of those events in our database, converting them back into in-memory objects. And then they're going to get set onto this event here, these events here. And actually this can error out, so we'll put an error on there to check for it. Okay. And then update, second error out. Okay. So now our print, we can say db events error. Okay, if error. Oh, that's fatal. Now we can loop over E range events. Okay, and F. We'll just put the ID and the user maybe. E user. Okay. db. Okay. Importer not used on main. So we're starting to pull stuff out of here. Not using bolts anymore because it's all wrapped up in our package here, EDB package. Too many arguments to return 40. Load, save the events, so you can't return. Kill it. Can't save the events. Okay. Save events to this. And print events. Save events. Okay. The bad sign. Okay, something broke. Got events here, returning from here, checking the error. Do we change the format? Yeah, we did. Let's try to kill that. Remove the data directory, or the data file, and then, oh, we didn't call anything. That would do it. So if we load the DB, it loads it in, and now we'll print it. Print DB. We need to put new lines on there. So when you do the printf, it's always a pain, but you have to put these new line characters on there because they don't append them by default. You use like puts in Ruby to put that on by default. Okay, so now we actually have data in there. And then if we actually put some more events in there, we can just keep loading. If it gets the same event again, like the same ID, it'll just overwrite it. Just wait a minute. Get some more events. Okay, more events. Put that out. We should have a lot more. There we go. Okay, so this is all, every time we run that load, it's being pulled and stored in the database. Now we have those events, you know, as long as we want, and we can mess around with them. Okay, so I don't have too much time left. I guess we can try to figure out what we're going to do next. So we have the print and the load. Basically, what we want to do. Actually, I don't know how clear the vision is on this project for people. That might have been a good thing to start with. So the idea, yeah. So we're pulling in. We're interfacing with GitHub and their stream of events. We basically want to call out to that endpoint every, like second or two, and get whatever new events are coming through. And I mean, technically, I guess we could just store events for everyone for all time, but we probably just want to filter that list down to some subset. So either something like that's in an organization, maybe like Turing, or some list of usernames. But yeah, as those events are coming through, we're going to be able to filter those out. So we'll have some kind of GitHub. I'll draw it all up there. So we're going to have. Okay, so let's okay. So we're going to have this guy here. Okay. So this thing's going to have our database is one part of it. Okay. We're going to have the GitHub interface. It's going to go out to the GitHub website, and then it's going to stream back, or it's going to keep pulling for those events, and then as it matches events from GitHub, it's going to push them up in the database. Okay, and then we're also going to add a HTTP handler right here. The handler here is just going to have like a we're going to have some sort of APIs for that. But that'll just, we'll have a client right here, call in, and then it can say, I want messages for all users, or I want a certain type, or we can fiddle around with the API however we want. The main thing is just getting data in there. So right now we already have stuff coming from GitHub. So we're like halfway there as far as that part. Got that, and we just need it to pull continuously. So we want it to run as a server in the background, and every second it can just run. And that's pretty easy to do. We can do that next time. But once the data comes back in the database, we start actually adding data. Let's see what else. One thing we do want to add on the HTTP part is that we can come and get messages. We can call into the HTTP handler and get messages or events. But it'd be cooler if we could grab an initial set of events and then stream any new events that come in. So this connection just stays open and it just continuously streams down new events. So we can do that, and then we have we make that client some visualization so that it can actually see events as they come in. So if you do a GitHub push, or someone at Turing does GitHub push, it'll do like unicorns, like answer whatever we want. Okay, we've got GitHub. What am I missing here? It seems too simple. Maybe it is. I mean, it's a fairly simple idea. Just it'd be nice to have the data up there so we can get to it. Yeah, I'm going to take a from here just say pull. GitHub and yeah, I mean, really, I think it's just those are two main pieces: the handler and the polling. Once we have the database. Oh, we need to split out the database too. Right now, we just have all events in one bucket. But what we really kind of want is we want to have our events bucket and then have like a user, like a Bob bucket inside of there, and then have his events, one after another, and then Susie right here. Our events right up there, so that we can go and stream in order. Because you can do some cool stuff too once you order by user. If you want to see like a session, you want to sessionize stuff, you can group stuff together by time. If you have idle time between stuff, you can see when people sit down and do code, they tend to push this many times or whatnot.
What's that polling thing?
Oh, this one right here. This is the thing that's gonna. It's kind of like it's just gonna call out through the GitHub API that we have out to the server. We're just gonna do this every 1 second or whatnot. We need to add our configuration file. Big file. Some people use JSON for configuration, but I think that kind of sucks because that other camel one that you get to the box works pretty well. And that'll just set up some like API keys or I don't know, something to do with that. Oh yeah, the other thing too. There's another one. So it's GitHub, and there's another one called the GitHub Archive. So the GitHub Archive has basically been doing what we're doing, like pulling this endpoint since like 2012. So they have a whole bunch of data from the past, so we could actually go out and pull from there. So they have like these just big old gzip files. We just get like gigabytes and gigabytes of data. We can pull it down and stream it through, filter it out, and then we can backfill our database from that. Yeah. Is there anything you guys want to do for a client for the visualization?
Did you play around with D3 on the last one?
Mm-hmm. Yeah. So we did the actually, I think I fired it up. I'll show you what we did. It's fun. Like the most pointless little app, but that's how they go. Slack has an API as well. I have to get these little authentication tokens off of it. But you can get all kinds of things from here. We have, oh, right there. Yeah, here's all the different API methods. But you can get, you can join, you can get the history of all the messages, you can get a list of all the channels, you can send messages, all kinds of stuff. So we just ended up, what do we do? We grab history, info. The API and got, for a set of channels, we just got all the messages. But we went and did some chat. Not running. Through. Okay, so then Slack. Okay, so it's called Cat Slack because it's Too Long Tuesday. So if you go install Cat Slack, D stands for daemon, whatever you want to pronounce it. Token, put the token in there. So it loads up our messages. Treating users. So we get like the avatars for people. And then it starts the server up. Go to that. So actually, before I show you the visualization, we have our messages with the JSON here. So we're actually just streaming out. This is all the data that we're streaming out for the visualization. It's just an endpoint that we have that's coming from our database. It's kind of the same thing that we're doing now. It's fairly similar. I forgot the visualization though. It's taking a second for them to pop in. There we go. So yeah, this is a force-directed graph. So we came through and like, you have nodes, and then you have the edges, things that link between the nodes, and then it uses basically kind of like magnetic forces almost, like to push nodes away, and then the links kind of hold them together at the same time. So that you can actually grab these and like that. And again, this is like the most useless graph ever. But you can see stuff like, I don't know, people that clap right here. Some of these aren't coming through. I don't know why. Yeah, over there. This one.
I saw Scott
Food train. What's that?
I saw Scott.
We're at the top a bit,
All right.
Oh, soccer.
but going to the right one.
What's that? Page up.
For sure.
So some of them you can do like, it's kind of interesting to see like who claps, like this one right here, Firebreaker. Jorge. He does a lot, man. I didn't realize. Got a little puppy dog. And these two over here. He's throwing off. But yeah. It's,
And then the one without anything is Slackbot.
oh yeah, which one
The
was?
poop and the octopus on the other side. So right a little more.
Right?
Right
It's
enough.
floating by itself, then, right?
Just the.
Oh yeah. Yeah. So
Jorge does it too. Is it Sad Spot?
what's that?
The one that Nathan, so right above Jorge, that's broken. Yeah. Yeah.
Oh, it's here?
Yeah.
That's good. Yeah. So there's all kinds of like, I don't know, cool D3 things. We're just kind of jumping through here last time. But yeah, like we're going to graph stuff out or.
I know the teachers are really interested in this, like weird trend that we all have of none of us or most of us have never touched GitHub before we start.
Yeah.
We start and it's like 6 weeks of crazy push,
Yeah.
push, and then 6 weeks, and then afterwards we get jobs and we're pretty much fall.
Just dead. Yeah. Yeah, I mean, you could do like a little Steam graph thing if you wanted to.
Yeah, that would be good.
I guess you could do that by cohort too. The colors. But yeah, D3 is its own world, but it's kind of fun just to. The cool thing about D3 is like once you understand the basics, they're all kind of the same. Like they use a lot of the same principles. I like this one. But the is that what's playing music?
You wait to the vacuum.
I've heard the vacuum. I didn't realize they did music.
Some people jam out.
Sure, they would start morning cleaning session.
I thought it was rich in the other room.
But yeah, I mean, you can just go through here and find all kinds of cool little things to play around with. This one's always interesting. I always try to find the reason you use like parallel coordinates, which you can basically, it's a bunch of different features, and you can filter out one of them and see how that maps to the other ones. And you can drag that around, filter it out.
Breadsticks, pickles.
Oh, yeah, there we go. So, yeah, so if you guys have any ideas. Space-time. That's just the current. Oh, okay.
Let's use that.
That's the
Data.
slowest moving animation. So, you can do all kinds of stuff. What's that?
The mower. What's that?
The mower?
That's the top.
Oh, this one here? I guess you can move it. Really? Oh, you can delete it, huh? All right. There's also good, we looked at it, or actually this is good. I saw this GitHub visualizer, we're like, cool, wonder what that is. The most confusing visualization you've ever seen. You have no idea what's going on. It just keeps popping more stuff up there.
That's the best. The base.
That seems exactly like Bernie.
Yeah.
And
So
all that stuff we saw at the beginning,
Oh.
you've never seen again.
Yeah, they're like two graphs.
Yes.
They're just like never gonna address them.
Yeah, so I think it's tracking, like, these are commits, I think, to this guy's repo, maybe. And then, like, a lot of people, like, this is the guy here. He's the guy that made D3. And then, I think it's, like, over time showing how they are coming in. It's so strange.
So you can like put it at different username.
Yeah, so, like, scared to know. What is it? Show. Yeah,
Oh,
this is
restart.
terrible.
Oh,
Oh, here's, okay, this is mine. Oh my God.
That's like
How are these grouped together?
good.
Well, the thing, I don't get this because, like,
Language?
maybe a multi primary or JavaScript.
ADVs
Go. I don't know.
go. Boxers go.
I haven't pushed up to this yet. It's just. Oh my God, there's so many settings. So anyway, make your visualization very simple. What's that?
I just don't understand why you weren't being shot with little
I don't know either. Yeah, so there's all kinds of fun little things you can do. But this one was interesting. It was like contradiction from the Bible. And it like goes from Genesis to Revelations. And the lines are, I don't know, it's interesting. Like just the way you think about things that are, I guess it's linear, but like you don't really think about it in this visual way. Yeah, anyway, animation, whatnot. But all kinds of fun stuff with D3. We'll figure out something. Did you ever do any more D3?
Didn't have time last week.
Oh, I can see that. Yeah. What did we get this week? All week?
Yeah,
Do D3?
it's true. It's true.
Okay, so yeah, if you guys have any ideas or whatnot. Just posting up in the Slack room. And yeah, should be fun. Yeah, once we get the data in there, we'll have it up. We'll put it up on DigitalOcean. Just anything we want to hang against it, and just keep running. Yeah, I got somebody over there gave me like a whole bunch of DigitalOcean credits. The guy was, what was that?
Okay.
No, it was John Edgar.
Oh, okay.
Like for some reason, like he really likes me. I don't know why, but he, like it's strange. But he just one day he was like, "Hey, I saw you didn't have any money in your account," or like, and he's like, "Here's $500." I was like, "What? Okay."
Yeah. Kenny keeps telling me that he'll give me $5. I think that's like their amount.
Yeah. That's crazy. And it was really sad too because they had like one little droplet running for like $5 a month. Like, you know, I could get through this in like 10 years. Yeah. So, any questions you guys have? Does that make sense? I know it kind of
It's a
like
good intro to it all.
was it okay?
I think it was, yeah.
I'm always curious
Yeah.
because I know like Chandra's she's been coming consistently for like months, so she's the expert in the group. But
No, Marcus too.
yeah, you guys have both come in like I didn't want to make it too intro. Yeah, we tried to do like the really like step-by-step intro and it didn't seem to
Which
sing
of
it as
those
well.
set up some tutorials? Or which of those do you recommend?
The tutorials. I think I've heard that the Tour of Go is confusing. People tend to recommend that, but or say that you should use that. But I think that's just because it's out there. As far as an intro, I've heard that the Go book. There's a couple Go books actually. They're usually not very long. Like the language itself. Do you guys ever meet Danny? What's his last name?
Bonds.
Gluns. Did you ever meet him? He actually came. He was in my cohort originally. This is just for the cohort. And
See.
awesome, yeah. And if you go on the Golang documents,
Are you still recording?
what's that?
Are you still recording?
Oh, probably, yeah. Okay.
Uh,
Hey, there's one viewer. Okay, we're signing off. See you guys.